in this video, we're going to sketch E and F. Now, it says here, sketch P of x, which equals sine 1/2 x, and Q of x, which equals cosine of 2x. State the period for each, and we will. Now, remember, to find the period of a trigonometric function, the period is usually 2 pi. But when there is a coefficient in front of x, or coefficient that is being multiplied to the x, whether if it's in parentheses or directly to it, the period of the function changes. I don't need to put the a there. I'm going to put sine of kx. Now, to find the period when there's a number, a coefficient to your cosine function, the period equals to 2 pi divided by k. And k is the coefficient of that variable of x. So to find the period in this case, and the period means how long will it take for your function to make one revolution around. The period for the function of P of x, which I'm going to do over here, and it's going to be sine of 1/2 x, is going to equal to 2 pi divided by k. And the value of k right there is going to be 1/2. You can't leave it like that, so you must apply keep, change, flip. Keep the top the same, which is 2 pi. Change the overall division to multiplication. Flip the second fraction, which is 2. 2 pi times 2 is 4 pi. So the period is 4 pi. So it's going to take a total of 4 pi for the trigonometric function to make one revolution. Now, because your period is different, your grid values are different as well. Your grid values will be stretched out by a factor of 2. But in this case, because you may not remember from transformations of functions, we have what is called an interval value. And the interval value is 1/4 times the period. And we use the interval value to find out the distance between every grid point. My period in this case is 4 pi. So that's going to be 1/4 times 4 pi. When I multiply that, that's going to be 4 pi over 4, which equals to pi. So the distance between each grid value will be a length of pi. And remember, I need 5 grid values. And we're going to start off with the first grid value, which is 0. Now, once again, to find the next grid value, you're going to add the interval value to the first grid value, which is pi. 0 plus pi is going to be pi. So that's 2. Plus pi, again, equals 2 pi. That's the third grid value. We can already see what the third one and the fourth one is going to be. Well, the fourth one and the fifth one. Because if I add pi again, 2 pi plus pi is 3 pi. And then 3 pi plus another pi is 4 pi. And once again, the period is 4 pi. So now we have our grid values. The number in front of the sine function is 1, which means the amplitude is going to be 1. When the number in front of the function is different, we can expect a different amplitude. Check that out later. So the highest value the function is going to attain is +1. The lowest is going to be -1. Once again, as we've seen in the last video, when the value in front of your trigonometric function is different, the amplitude will change. And remember, this is a sine function. Remember the pattern. It is 0, max 0, min 0. Say with me for sine. It is 0, max 0, min 0. And this right here is P of x equals to sine of 1/2 x. Now you do the same thing with the next one. It says cosine of 2x. Q of x equals cosine of 2x. And make sure you have this down as well. So now we're going to find the period. To find the period, it is 2 pi divided by k. And the value of k in this case is going to be 2. So 2 pi over 2, which is pi. So in this case, it's going to take pi revolutions to go around once. Now we need to find the grid values. And to find the 5 grid values, we're going to find the interval value. And remember, to find the interval value, which is the distance between every grid value, that is 1/4 times the period. In this case, 1/4 times pi is pi over 4. The first grid value is 0. Let's put that there. To find the next one, we're going to add pi over 4 to 0. 0 plus pi over 4 is equal to pi over 4. Second grid value. Add another pi over 4 again. Pi over 4 plus pi over 4 is 2 pi over 4. But please remember, and I will deduct points if you don't do this, you must reduce this fraction. Pi over 4 is 2 pi over 4 is reduced to pi over 2. You must reduce your fraction because 2 over 4 can be reduced to 1/2. 2 pi over 4 can be reduced to pi halves. Now, add another pi over 4 from the non-reduced version. And that's going to equal to 3 pi over 4, which cannot be reduced. And last but not least, add another pi over 4. And that's going to equal to 4 pi over 4. And 4 pi over 4 reduces to pi. We have our 5 grid values. And remember, the number in front of your cosine function is 1, which means the amplitude is going to be 1. The highest value the function can obtain is 1. The lowest it can obtain is -1. Let's place those grid values on our axes. So that's going to be 0, which is already there. Now, pi over 4. I want to put pi over 4 right here. Pi over 2. 3 pi over 4. And then pi. Matter of fact, you know what? I'm going to space it out instead of doing that. And remember, this is cosine. Remember the rule for cosine when you sketch it. Max, 0, min, 0, max. That is for cosine. Max, 0, min, 0, max is for cosine. For sine, it is 0 max, 0, min, 0. Write that down somewhere. And that is how you sketch this function. The period in this case is pi. It takes pi revolutions for the function to go around 1 complete time. And then what I'm going to do is for this next one, after you have this down, we want to sketch the function r of x, which is equal to 2 sine of 1/2 x, and s of x, which equals to 1/2 cosine of 2x. Find the period, the interval value, and the grid values. State the amplitude for each. Now, this one is pretty straightforward. It's the same, except the amplitude is different from the other function. Now, let's start with r of x. R of x equals to 2 sine of 1/2 x. We already found the period. The period is going to be 4 pi. That was the first graph we sketched in section E. The interval value was pi. The grid values in this case is 0, pi, 2 pi, 3 pi, and 4 pi. And I'm about to place those grid values on the x-axis. 0, pi, 2 pi, 3 pi, and 4 pi. And then it says state the amplitude. For us to find the amplitude, that is going to equal to the absolute value of the number being multiplied in front of my trigonometric function. So the absolute value of 2, which equals to 2. And if you notice, for section F, we're essentially combining section E and section D together. The amplitude for section D with the periods from section E gives us the function for section F. So the amplitude is going to be 2. So the highest value the function can obtain is 2. The lowest it can obtain is -2. And remember, this is a sine function. So when it comes to sine, it is 0, max, 0, min, 0. Sketch. R of x equals to 2 sine of 1/2 x. S of x, 1/2 cosine of 2x. Now remember, we did that in section E. The period of that was pi. The interval value, pi over 4. My grid values, remember I have 5. 0, pi over 4, pi over 2, 3 pi over 4, 2 pi, 1 pi, because that's the period. Let me put those grid values on my graph. Pi over 4, excuse me. Pi over 2, 3 pi over 4, and then pi. The amplitude is the absolute value of the function being multiplied in front of the trigonometric function. The absolute value of 1/2, and that's going to equal to 1/2. So the highest value this function can obtain is 1/2. The lowest value this function can obtain is negative 1/2. And now remember, when it comes to the cosine function, it is max. The maximum value this function will obtain is 1/2. So max, 0, minimum, 0, and then back up to the maximum. And that is how you are sketching this function. Like I said, it has the amplitude from section D with the period, the interval values, and the grid values from section E. 17-minute video. It's really long, but I want you guys to use this as reinforcements. I'll see you soon. Take care.